Oceans Conference, this is Mission Control Houston. Please call station for a voice check.
Station, this is Oceans 2018. How do you hear me?
Hey, Oceans 2018, this is the International Space Station. Welcome.
Thank you, Serena. We welcome you to 2018 Oceans here from Charleston, South Carolina. Well, we'll get right into it. During your time at the ISS, you've certainly developed a new perspective on our home planet Earth as a complex and dynamic system that we don't yet fully understand. And so we're excited to better understand our oceans and observation technologies through your eyes and the exciting things aboard the ISS right now. And with that, I guess I'd like to just start with the question, because I know our time is limited. Can you talk for a minute about your priorities for Expedition 57?
Yeah, absolutely. Of course, one of our biggest priorities is science. We launched on June 6th and got up here and started with the science right away. And when I say that, I mean everything from material science to atmospheric science, ocean science to human science. And it's interesting in that a lot of what we perform up here, some of that we learn on the ground, but a lot of it we don't learn about it until we get up here and interact directly with the PI themselves. And so it's been kind of a surprise to see some of the experiments that we're doing, and very exciting too, because I didn't realize the potential that some of these had to impact the Earth as much as they did.
That's great. We've got a lot of interesting technologies here, but I was wondering if you could give specifics on what phenomena on Earth are monitored from the ISS and how that data is collected and ultimately transmitted.
Yeah, absolutely. So some of the things we've had in the past and currently, one of our main payloads was called HICO, and that was something where we collected over 10,000 photographs of coastal areas around the planet, and we were able to look at everything from water quality to onshore vegetation to harmful algal blooms that may have occurred in drinking water reservoirs. Another neat one I like to talk about is RapidScat, and RapidScat was one of the first spaceborne scatterometers that was able to look at real-time monitoring of ocean winds. And so it was helpful with marine forecasting, but also tropical cyclone monitoring. And it was really one of the first scatterometers that was developed up here for us to monitor those things. And so we're very proud of those because, you know, and those are examples of payloads and sensor systems. And sometimes what people forget is one of the best internal payloads we have here on the ISS is us, the astronaut, with our eyeballs, because we're able to see so much at varying lighting and at different times and give our own unique perspective on what's happening globally.
That's great and certainly relevant for our group. I was wondering if you could also talk to any specifics that would be relevant for the scientists and the engineers studying the oceans here in Charleston.
Well, you know, it's interesting. One of the things I'm also proud of is we recently, with the help of our international partners, installed something called DSIS. You may have heard of this. It's out of the DLR program in Germany with the help of Teledyne Brown. And this is a hyperspectral sensor system, which allows us to look at water composition and water quality. And I think that's important because as we have natural disasters, things such as oil spills, which can happen on any coast, of course, coming from Texas, it's important there, but it's important across any coastal area. We'd like to know what the composition of that contamination is. And this DSIS, which we installed really just a few months ago up here, is going to help us take a look at that.
One of the things being discussed right now, and I think the Vice President mentioned this yesterday, was the role of the private sector in space-based research. Can you talk about that role a little bit and how it's going to impact the ISS and more broadly ocean science?
Yeah, absolutely. So when I think of the private sector, certainly the science we do up here already. So the private sector is already fully integrated into a lot of the research that we do. In fact, DSIS, like I just mentioned, with the help of Teledyne Brown, that's how we developed that system. And what's important for the private sector is how can we develop new technologies without developing an entire satellite system around that technology? It's very expensive to have to develop a satellite to test one sensor system. So what we were able to do with DSIS is create that sort of sensor system and bring it up and test it on ISS, which is a far cheaper way, believe it or not, to test this out. And so ISS has been able to do this with several payloads, both external and internal, and actually save a lot of money in the long run. Now, I'm a physician, so I've got to put my plug in here, but we do a lot of research with outside companies to look at changes in medicines, to look at changes in the human body in space. And one of the experiments we performed a few months ago was actually looking at cancer research. And you think, well, how could that occur on the ISS? Well, cells themselves like to grow in microgravity. And so it's one of these things where they think they're in the body, they live a lot longer, and it actually allows researchers to test cancer chemotherapy agents. One of the other exciting things going on, I don't know if you can see down here to my left, but there's this orange tape. Well, this is an experiment called BCAT, which studies sedimentation, and it's out of the National Science Foundation. And so it's basically just a mixture of clay, silt, and sand. And what they're looking at are something called cohesive forces. I know you all know what that is. And I know that's difficult to study on the ground on Earth because gravity is such a powerful force compared to the relatively weak cohesive force. So when they brought their samples up here to the space station, it was initially planned only for about a month or so. But they've been so excited by the results that they are extending this experiment right now because they're really very well able to study that cohesive force up here, and they're getting results they did not expect. And I'm kind of waiting for the PI to get back to us because we interact with them on a weekly basis to help them gather the data that they need. And so, of course, if we could study sediment up here, it better helps us to explain sediment travel and pollutant travel in our water reservoirs and our water systems down on Earth.
That's great and very informative. The next question might be mine. I have spent most of my career studying severe weather and specifically flying into hurricanes, but the view is not necessarily the best for us. Can you tell us a little bit about your view from the ISS and specifically how the ISS supports severe weather prediction here on Earth?
Yeah, absolutely. So one of the first things we do, certainly we are almost as busy during hurricane season as you guys are because we get such a bird's eye view of these storms as they form, as they strengthen, and as they approach the coast. And I can't even explain to you what it's like to fly directly over the eye of a Category 4 hurricane, which we did not that long ago. We passed over Michael. To be able to peer down directly into the eye and look at the changes in the formation and watch how that hurricane strengthens. And so certainly we're used a lot up here for imagery of these severe storms as much as they can, depending on where the ISS is passing over the Earth. But even after the storm has done its damage to a community, to a coastline, we're able to take pictures of the extent of that damage from our perspective, just to kind of show the devastation, unfortunately. And we were doing that with the Florida Panhandle just the other day because you could see those coastal communities that were wiped out and the damage that was done from the storm. So it's certainly not the same as flying into it. That definitely takes a lot of guts because we see the strength of these storms and the immense size up here. And it's from our beautiful window to the Earth, the cupola, where we get a bird's eye 360 view. And it is some of the most impressive, probably one of the most impressive things I've ever seen from the space station.
I've seen those pictures, and they truly are inspirational. But I'd like to shift gears here for a second. We've got a lot of students in the room. And could you comment on how the ISS influences or even makes opportunities available for students of all ages to be involved in space-based research?
Absolutely. So there are so many opportunities, starting with, I'll start with the little ones. We have something called EarthCam, where classrooms can control a camera we have mounted here in ISS to take varying pictures of Earth's topography during the daytime or even the nighttime. We also have our ARIS program, which is where students utilize amateur ham radio operators and make contact with the ISS, and we talk to them. In fact, later today, I have another ham radio pass with a school in Delaware. As you get older and climb up that tree and you're in high school and college, there are plenty of internship opportunities at every NASA center around the country. It's easy to find. Just type in NASA internship and you'll see what's out there. But a lot of the science, amazingly, a lot of the science I've seen up here, even the CubeSats, which we launch from this right here. I put them in this Japanese airlock right behind me and send them out. These are from students from multiple universities across the country trying to test out technology. And it is amazing at how individual universities, a good portion of them, have partnerships set up with NASA to make the science happen. The information is out there. Everybody's good with the internet. Take a look. But certainly, if you have any other questions, really just Google Space Station Science, research opportunities, what's out there for me, and you will find a lot of information.
That's great. You mentioned the Japanese airlock, and we've got a lot of international partners here in attendance. I was wondering if you could talk a little bit about how those partnerships work for the ISS and why that partnership that's now been extended to 2024 is so important.
You know, it is, so right now we have one American, one German, and a Russian on board the International Space Station. And honestly, we are one family, and we always have been. International partnerships are so important because it's the only way the space station functions. We all bring different ideas when it comes to science, different ideas when it comes to technology demonstrations. When we check in with Mission Control, I think people traditionally think of Mission Control being located in Houston, and what they don't realize is that every day we interact with Mission Control in Houston, in Moscow, in Munich, in Japan, in Huntsville, Alabama, because they help us organize our science all over the world. And so what this platform has been able to demonstrate is that we can take something technologically so complex and so challenging and make it work. Multiple languages, multiple meetings, and my international partners who are down there tonight, you understand what it's like to have to get up at 4 in the morning because for this country it's this time and this country it's that time just to have a meeting. And we're used to that. That's how the space station works. It cannot work alone. It cannot work with just one country. We've always worked together with this, and I don't see that ending anytime soon. I think that will continue into the future.
That's great, and I think we have similar partnerships here in the building. But I did want to talk about your personal experience. I mean, so much that happens aboard the ISS is that giant leap for mankind. But for you personally, can you talk a little bit about some of the other experiments that you're involved in and what your typical day might look like on the ISS?
Yeah, so our typical days are really busy. We're pretty much starting by about 7:30 in the morning and don't end till 7:30 at night. Right now, it is definitely packed with science, so I'll tell you about some of that. I talked about the sedimentation science right up here to my left, which we do pretty much almost every other day. Another science experiment that I've been working on is actually sequencing DNA up here on the space station. And really the first time that was done was a couple years ago, and now we're expanding upon that to see if we can see mutations in that DNA on board the space station. The cancer therapy research, which I worked on not that long ago, for about 2 months, was extremely rewarding. About 40 feet from me, also in this Japanese module, is something called plant habitat, where we are growing Arabidopsis plants. And it's very interesting to watch how plants grow when there's no gravitational cue. Just like it's interesting to see what this sediment does when you take away gravity. What other forces are at work? You know, in the plant habitat, sometimes the last time we harvested, we noticed that they grew in all sorts of different directions. So plants sometimes need a gravitational cue to tell them how to grow. And when that is absent, how does the plant respond? The other thing we're experimenting with that is, you know, we're not using a soil-based system, we're using a nutrient-rich mixture. And due to surface tension forces, how do we water plants? How does water act up here? Probably one of the biggest surprises that I came across when working up here, even though I'd heard about it years and years and years, was surface tension forces. How does water respond? How do fluids respond? And I got my first introduction the first couple weeks when I did a experiment on cement mixing. And you think, well, you know, why is that important? Well, at some point, we're going to be off this planet creating other structures, other habitats, other facilities on different worlds. And when we do that, we need to know how cement mixes. We need to know what sort of impurities exist within that system. And I was talking with the PI directly, and we were looking at how the cement mixed and looking at everything. And they thought the water would act a certain way, and we learned that it didn't, and that we had to make certain exceptions for how we mix the cement just based on forces that are only present up here in the microgravity environment. And so that was really enlightening to me We don't do experiments too differently. What we have to learn is how to work around what microgravity causes. And so most of our days are packed with science, but we do a lot of maintenance. The station has been around a long time, and so we do maintenance to make sure things are upkept well, and then maintenance to fix things when they're broken. We fix the toilet a lot. It happens, but it's one of the most used things here on board the space station, as well as our exercise equipment.
That's great, and I have to ask, thinking about the big blue marble, has seeing the world's oceans from space caused you to think a little bit differently about them?
You know, the other thought when I got up here, when I first went to the cupola and looked out the window, was, wow, I felt really close to the Earth's surface. And what was amazing for me was to see continents that I had never seen before. To see, and what you can really pick out, and what they train you to pick out, are huge rivers, waterways, the ocean system. That's how you recognize things. And to be able to see one continent and then look to your right and see the next continent coming just gives you this huge global perspective. Almost the neater thing almost was a few weeks ago when we had our Japanese cargo vehicle, HTV-7, literally launch, pull up next to the space station. So when I looked out that window and I saw the Earth, I saw this other vehicle out there waiting, like waiting to park in a parking space, doing the maneuvers it needed to do to pull into station so we could grab it with the robot arm. And it really makes you stop and take a step back and look at how far we've come, where this is almost routine. And I knock on wood when I say that, because it's never routine. But to see a vehicle just pull up like that and park itself on the space station, and very soon, in the middle of November, Northrop Grumman will be launching their vehicle, and SpaceX soon after that. And so it's just become almost the norm to have these vehicles pull in and pull out. But it blows your mind a little bit, because 20, 30 years ago, that was not the case.
So I've been told that we're quickly running out of time. We do have an eager audience here watching and listening to our conversation. Do you have any parting words for those of us here in Charleston attending Oceans 18?
You know, I think the best thing I can say is how important the work is that you do and how important conferences are to go to. I'm a physician. I go to conferences all the time. This is where ideas are spread and where ideas are invented. And it's by going to conferences, meeting people, networking, interacting, and sharing ideas. And so what I would tell young folks in the audience, especially students, is if you're at this conference and you meet somebody or you see something that you're really interested in, go talk to them, go bother them. I think a lot of folks won't ask questions or go any further because they feel that they're bothering people, these very important people giving all these talks and demonstrating technology. But that's your job. Your job is to find out more about this so you can contribute to it in the future. So don't be afraid. Walk up, ask your questions, and bother.
I'm going to go bother someone after this. Well, Doctor, thank you again from Charleston. We all really appreciate your time this morning. Godspeed on the rest of your journey, and best of luck to Expedition 57.
Thank you so much from the crew up here. I really appreciate it.
Station, this is Houston ACR. That concludes the event.
Thank you, Oceans Conference and participants. Station, we are now resuming operational audio communications.